Right, okay. Over here, today our topic is to learn about the numerical methods. Numerical methods. So in this case, what you need to understand is like from a sample kind of example, let's try to understand the situation. We will get some kind of a function. We need to solve this one. Look at this. If you need to solve uh, e to the power x plus x, uh, yeah, minus 1. We need to solve this equation. Right. In this case, we don't have any kind of a way of doing this simplification. Right. What I'm supposed to do is I'll just consider this function as fx. Look at this how I'm going to do it. Plus x minus 1. I'll get some x values just like minus 3, minus 2, minus 1, 0, 1, 2, and 3. And I'm going to get the values for fx, the y values. So I can get help from my calculator to get this answer. Starting from minus 3 to plus 3 from step 1, right? If you get these answers, you can see this is turned up to minus 3.9 and this is minus 2.8. It's minus 1. If I put 0, it's 0. Then again 2.71, 8.3, and 22 point something, 22.0, right? Then if I plot this graph, what you can understand that. If I plot this graph, you can see at minus 1, minus 2, and minus 3 I'm referring to, and it's 1, 2, and 3. At minus 3, it's minus 3.9. So we will get the figures over here. We will get so like 5, 10, 15, 20, 25. This is the y values, and this is minus 5, minus 10. Yeah, that's it. So minus 3, it's minus 3.9 somewhere here. At minus 2, it's minus this, and at minus 1, that is also turn up to minus 1 somewhere here. At 0, it's 0. At 1, it's 2.71 somewhere here. It's 8.3, it's somewhere around here. And 3 is 22, it's somewhere like this. Right. Then if you plot this graph, you can see it's a graph somewhere like this. Obviously, we get a solution over here. We can see at this point, this is the solution for this one. For this equation, we get only one solution. That solution is how much? So you can say this value is, you can say x equals to 0 is a one solution for that. Is the solution for fx. But that is a point where I meet with the x-axis. That is a point where it satisfies the equation fx equals to 0. Understood the concept? Right. Then
Yes,
if you
sir.
come up with a question like this, then you get gx. Sorry, we need to solve this equation. I need to solve this equation. Sin x minus x equals to 0. Then we can say if you bring this x to other side, turn up to sin x equals to x. Therefore, x equals to sin inverse x. You can't do this kind of a simplification. For this kind of situations, what we can get here, so you can say, yeah. So for this case, I will consider this sin x minus x as some kind of a function. Fx equals to sin x minus x. Then I'll substitute the values for x. You will get x equals to, it's in we will get like some kind of like radian facts, minus 2 pi minus 3 pi by 2 minus pi minus pi by 2 plus, sorry, 0 pi by 2 3 pi by 2, sorry, pi by 2 it's pi 3 pi by 2 and 2 pi. Then let's substitute these figures and see whether what are the solution for this. Then you get fx. If I just substitute here, your calculator should be operated in radian mode. We can put initial sine x, sine alpha x minus alpha x, starting from minus 2 pi, ending from 2 pi. Step is, yeah. So this value is put the minus 2 pi value is 6.2. This is 5.7, 3.1, 0.6, 0, minus 0.6, minus 3.1, minus 5.7, and it's minus 6.2. So obviously here you get a one solution where the solution is x equals to 0. For this case, you don't need of drawing it because straightforward we have a solution over here with it, right? X equals to 0, right? Now let's come up with this kind of situation. You get a value, you need to solve this function with it. We want to solve square root of e to the power x plus, we'll get one example in the textbook itself and we will see with this. The thing, we'll get solved, you know, ln x plus 1 over x equals to 0. Ln x plus 1 over x equals to 0, right? Then if you sketch this graph there, what you can get here is that initially we can get this function fx equals to ln x plus 1 over x. Now I'll substitute some x values with it. Yeah, ln 0 doesn't exist, so it can from 1, 2, 3, and 4. Then we will get these fx values for these ones with it. Then you can see this is ln x plus 1 over starting from 1 ends from 4, step 1. So if you get these answers put there, sorry, this is we'll get this 1 minus 1 over x, and other than that you don't get a solution for this. 6 minus. Yeah. Over here, one value is minus 1 and 2 is 0 0.2, 0 0.7 and 1.1. Then if I sketch this graph, now this is the point where we can understand. You can see at 1, 2, 3 and 4. These are the x values and the fx values with it. Y values, right? It should be minus 1. It's here. At 2, the answer is 0 0.2. At 7, its answer is 0 0.7. At its 1.1. Like this. Then if you draw this graph, you can see its a behavior is somewhere like this. Now you can see this is the point where it meets with the x-axis. So this is the point where ln x minus 1 over x is equals to 0. At that point only the y value becomes 0. That means ln x minus 1 over x equals to 0. That is the, so in this case, this is the solution for ln x minus 1 over x is equals to 0. Then we know that, we know from the diagram, the solution exists in between, where to where, in between 1 and 2. So you can say it's kind of a 1.1 or 1.2. We don't know straightforward. How to get it later on, we'll come up with that, how to find the solution. Now, this is the way of identifying some kind of rough boundary where the function exists. Right? Okay, that is the initial step of doing this question. Yeah. When you're looking into some kind of function fx equals to 0, solutions of fx, when you're referring to whatever the function of solution of fx, if you go for a graphical answer, you can see it can be somewhere over here. So this is the point where the solution for fx equals to 0. Then if you get 2 points nearby, what you can see, one answer is positive and the other answer is how much? Positive. So you can say 4. So you can say near, if we consider two points beside the solution for fx is equals to 0, we can see the sign changes. We can see the sign changes like this. So like that, when, or you can say this way as well. Here also the same condition. So this is the point where the fx is equals to 0. With that, if you get 2 points beside this one, this side is negative and this side is positive. Okay, now let's go ahead with some kind of a question and let's try to understand this one. Now, if you come up with a situation somewhere like this, we will get one example from the textbook. It will be kind of easier. Suppose that x squared minus root x minus 10. So you need to solve x squared plus root x minus 10. Minus 10. We need to find the solution for this. Right. Then if you get x equals to, we'll put some figures 0, 1, 2, 3, and 4. Right. Then if you get the function fx, if you substitute 0 into this function, we'll just put it in the calculator and we'll try to get it. Start from 1 and end from 4. Steps 1. So you can see this answer is the minus 10. At 1, it's minus 7.4. At minus 2.7. The next one is 4. And the next, yeah, that is 4. So if I just put 4, 1 second. Something minus 10, minus 7.4, minus 2.7, 4 and so I just made the figures are wrong. So it should be 0, 1, 2, 3, and 4. Yeah, and if I put 5 here, look at this, what happened if it is 5. 4, after that with the 12, 12.7. Then if you plot this graph, what you can see, look at this, this is situation. So you can see, yeah, if I just put minus 10, minus 5, 5 and 10, it's minus, it should be 1, 2, 3, 4 and 5. At 1, the answer is minus 10. At 2, it's minus 7.4. At 3, it's minus 2.7. At 4, it's 4. and it's 12.7 somewhere here. Then if you plot this graph, what you can see, this is the point where the solution exists. Fx equals to 0. And then you can say x squared root x minus 10 is equals to 0. That is in between where to where. So you can say solution is in between where to where. 3 and 4. So later on we learn how to get the exact point over here, but at the beginning initially we have to identify it remains in which boundaries. That is the first objective of this topic. Understood? Right. We'll go ahead with this.
Yes.
Yeah. Yeah, this is the part of this one. Right. Now what you can understand is now one common property we understood from this question is if there's a root exists, the sign changes in a function. But there are some kind of situations like this as well. It can be this way also. Sometimes the function can be just like this. It comes over here and it goes over this side. It's also possible. Here also you can see the function is like this a solution with it. So for this function xx, so you can say fx is equals to 0. This is a solution for this one. But you can see that now the sign does not changes, right? The sign does not changes. But if you get two nearby points, two consecutive nearby points, you can see the functional values are what happened with it. Almost similar. The functional values are almost similar. So if you just put it, you can say sometimes at 2 points beside the solution of fx0, the sign does not changes but remain same sign with very close by solutions. Very close by solutions. Right. Just for example, we'll go ahead with one example with that. Like if you consider a solution just like this, y equals to x squared minus 4x plus 4. Right. Now look at this. If I get 2 points, if I get the points x equals to 0, 1, 2, 3, and 4. Right. Okay. Then if I put the y values, it's if I put 0, 4. If I put 1, 1 squared minus 4, 1, 4 is it's 1. If I put 2 here, alpha x squared minus 4 alpha x plus 4. This value 4, 1. But this is 0. But I just, it is not that applicable for this. We will get plus, yeah, this is 0. So like we'll get straight. It's 0. And if I put 3, 3 also 1, and this one also 4. Now you can see if this is here now you can straightforward, you can get the solution over here. But so if I plot this, you can see it's 1, 2, 3, and 4. The y values are 1, 2, 3, and 4. One value is 4. 0 value, sorry, 0 value is 4. 1 is 1, 2 is 0. Here it's this, and here it's this. Now you can see if I sketch this graph with it. This is the point of solution. This is a solution of fx equals to 0. But if you get 2 points, 2 close by points, look at this here. If I get 2 close by points, somewhere like here and here, you can see the roots are almost similar. So that kind of a situation also we can see in certain aspects. So more in prominent situation is we can see the situations with the functional value changes from negative to positive or positive to negative at 2 points beside the solution. So in this case, that is the initiative step of finding the root for a certain function fx equals to 0. Initially, we need to find during which range, in between two figures where the function, the roots of the function exist. After that, we minimize the range and we'll come up with this kind of exact solution. That's a way of doing it with it. Right. What we can do here is they ask you to show that this function has at least one root in the given interval. So this given interval, you have to show that there is a root exists over here. The first function is put the x cube. The first function given here is x cube minus x minus plus 5. Plus 5, we need to show that root exists in between minus 2 to minus 1. Put it. Minus 2 to minus 1. This is pretty simple. Initially, we'll substitute minus 2. What do you get there? Minus 2 cube minus minus 2 plus 5. It's minus 8 plus 2 plus 5. It's equals to minus 1. Then we will put other range. Minus 1. Minus 1 cube minus into minus 1 plus 5. It's minus 1 plus 1 plus 5. What happened with it? It's 5. Now you can say the sign changes with it. So you can say when x goes from minus 2 to minus 1, the sign of fx changes. This is how you write the answer with it. Therefore, a root exists in between minus 2 and minus 1. That is a way of writing this answer for this kind of a question. Right? Okay, let's go ahead this. Yeah, this is the one. Yeah, if you come up with part C, fx equals to x cube minus 1 of x minus 2, we have to show that the root exists between minus 0.5 to minus 0.2. So if you just do it back, what we can do is this way. The function fx is equals to x cube minus 1 over x minus 2. X is in between. We have to show that, sorry, it's equal mark won't come because it's an inequality with the range. It's, you have to show it's in between minus 0.2 to minus 0.5. That's a way of getting this, right? So what you can get here is initially we'll substitute minus 0.2. What do you get? Minus 0.2 cube minus 1 over minus 0.2 minus 2. So we can get this answer to turn up to minus 0.2 cube, 0.2 cube, 0.2 cube minus 1 over minus 0.2 minus 2. That value is 2.992. 992. Then if you put f minus 0.5, that is 0 minus 0.5 cube minus 1 over minus 0.5 minus 2. So if you replace this minus 2 with minus 0.5, you get the answer minus 1.25. Sorry, minus 0.125. So what you can say, the sign changes. So you can say when x goes from minus 0.2 to minus 0.5, the sign of fx changes. Therefore, a root exists for fx in between minus 0.2 to minus 0.5. That's a way of getting this answer. So right. Now that is how you need to do this kind of a question. But let's see the question number 2. Fx equals to 3 plus x squared minus x cubed. Show that the equation has a root in the interval of 1.8 to 1.9. So what you can do here is we will substitute f1.8. We will just do it and see. Just so if I put f1.8, if you do this, you get the answer 3 plus 1.8 squared minus 1.8 cube. That is 0.408. F1.9, if you put it. 1.9, it's minus 249, minus 0.249. So in this case, what you can say, you have to write the answer. When x varying from 1.8 to 1.9, the function, the sign of the function changes. As a result, root exists in between 1.8 to 1.9, as what we taught the previous steps in the resonance. Then they mentioned by considering the change of sign of fx, the substitute interval verify alpha is equals to 1.864, correct to 3 decimal places. This is the way of doing. This is a, we know that this is kind of like solution for this cubic equation to correct to 3 significant places. We need to show that how do we have to show root is this much correct to 3 decimal places for this cubic equation. Let's see how to do this question for them, right? Now, this is the way. The function fx is this. If you just go ahead with this, 3 plus x squared minus x cubed. This is a function. This part of it. Then we need to show a root is correct to 3 decimal places. This is the answer. We need to show alpha equals to 1.864 correct to 3 decimal points. Correct to 3 decimal points, right? This is the way of getting this. Initially, if it is for 3 decimal point, we have to do like this. 0.000, put 5 over here. And add and write one answer. 8645, one answer. And subtract this amount and first add it, then subtract it and get the other answer. If you subtract it, what do you get? 1.8635. Then substitute these figures over here. 1.8635 would be 3 minus 1.8635 squared minus 1.8635 cubed is equals to 3 minus 1.8635 squared minus 1.8635 cube minus 6.14. 6.14, right? The next one is 1.8645. Yes. 3 minus 1.8645 squared minus 1.8645 cube. If you just replace with this, sorry, I think for the previous answer I made a mistake, seems to be. This is put a minus 6.96. Yeah, that is true. 6.94, not 14. 94. Then what you, sorry. Yeah, 94. The other one is, if I put 45. Now in this situation today, you can see the sign does not changes. When, this is the way of writing the answer for this today. When x goes from 1.8635 to 1.8645, the sign does not changes, but if 1.8635 is close to f 1.8645. Then you can write, therefore, a solution exists in between 1.8635 to 8645. We can say the root 1.864 is correct to 3 decimal points. That's a way of writing the answer for this question. You can do the first part of the question by just getting substitution and get this answer. And second part of the question, you can do it in this way. Sometimes you can see situations where the sign does not changes, but they are almost similar figures. With that also we can say a root exists in between those two ranges. That's a way of doing it. Okay, let's do this question.
Okay.
We come up with this question for the hx equals to cubic root of x minus cos x minus 1. Show that root exists between 1.4 to 1.5, and by choosing a suitable interval, show that alpha equals to 0.441 correct to 3 decimal places. So you can get this answer. Come up with this. You can say fx equals to cubic root of x minus cos x minus 1. Cos x minus 1. Initially, we need to show that root exists in between 1.4 to 1.5. So we will put f1.4 and f1.5. So if you just put 1.4 over here, minus, okay, when you operate in this particular, the angle should be in radians. Other than that, you don't get the answer for that. Cos 1.4 minus 1. So if you didn't get the answer for this, you have to make sure that check whether the operations angle format is correct. Minus 0.05. It's one. If I put 1.5, 0.07. Then what you can get here is that you can say when x goes from 1.4 to 1.5, the sign of fx changes. Therefore, a root for fx equals to 0 exists in between 1.4 to 1.5. That's a way of writing the answer for the first question. Part A. Then part B, we need to show that root one root is 1.441 correct to 3 decimal places. Alpha equals to 1.441 here. Then correct to 3 decimal places. In that case, we can get 0.0005. Add them and get a 1 factor of it. 14415. Subtract it if you get 144. This is 15. The other one is 0.1. So 0.1441 minus 0.0005. Is 14405. Yeah. So what you can get here is that now we replace that value over here with f 1.4405, and the other one we had to put 1.4415. If you replace into this original function, that is cubic root of 1.4405 minus cos 1.4405 minus 1. So we'll do it and see. Cubic root of 1.4405 minus cos 1.4405 minus 1. That is minus 5.5 into 10 to the power minus 4. Oh, if you just write with from the term 0.00055 minus. Then if I put 4415, let's see what that answer to that. That is this today. Cubic root of 1.4415 minus cos 1.4415 minus 1, it's equals to 6.988 into 10 to the power minus 4. So that is 6988. So in this case, what you can say for this? So obviously we can say when x goes from 1.4405 to 1.4415, the sign changes. Therefore, the root exists as 1.441 correct to 3 decimal points. That's a way of writing the answer for this question. So if I just work with, make it a little bit of smaller, then you can see the entire answer at 12. So that's a way of doing this. If you come up with this question number 5, fx equals to 2 plus tan x from 0 to pi, where x is, x is measured in radians, show that it changes the sign from 1.5 to 1.6. So remember that always we have to operate this one in the radian mode, because they have specifically mentioned this is in radians. So if I put f1.5 and f1.6, see whether what will happen with this is, if I just put 1.5, that is 2 plus tan 1.5, it's 16.1, and if I put 2 plus tan 1.6, it's minus 32.23. Then with that you can say the solution exists with this. State with reason whether or not fx has a root in the interval of 1.5 to 1.6. So you can say the sign changes, sorry, when, answer for this question is when x goes from 1.5 to 1.6, the sign changes in fx. Therefore, a root exists in between 1.5 to 1.6. That's a way of writing the answer for this particular. Right. Okay. Yeah. Right. Then we'll Go ahead with this. Cos 2x, cos 2x. Cos 2x means, we'll see, cos 2 times of, the first one is 0 0.2, 2 into 0 0.2. Yes, so this answer is minus 0.44, right? Then the next one is 0.8. If I just put 0.8, we'll see what is that answer, 0.8. Yeah, 0.8 answer is minus 1.47. 1.47, sorry, minus 0.147. 147. So you can see the 0.2 according to this one, it's a point somewhere over here. The 0.8 is a value somewhere over here. Then you can see how many solutions we can see. We can see 3 solutions. According to the diagram, we can see how many solutions. Yeah, you can see 3 solutions. So after that, what you need to do is further calculate 0.3, 0.4, 0.5, 0.6, 0.7, and you can get these answers. We'll just substitute and see. If I put these values, we just you can put this one in from your calculator and you can obtain this answer. Minus 6 cos 2 starting from 0.3 and from 0.7 and step is 0.1. Then if you just do it, but then you get the answer. Here the answer is 1.02, 1.03 actually, 5.96, 0.96. Something went wrong. 1 second. 105 alpha x cube. Sorry, just one part is missing. Yeah, we have to put it back. 105 alpha x cube minus 128 alpha x squared plus 49 alpha x minus 6 close bracket cos 2 alpha x started from 0. Yeah, sorry, these answers are kind of different. This answer is 0.3, answer is 0.01 per day. 0.01 here, it's minus 0.11 minus 0.2. This answer is 0.6 and this answer is 2.7. Then you, sorry, 0.27. Now you can see the sign changes from here to here and again here to here. That means there should be a root exist. Use your answer in part A and C to improve the conclusion about the number of solutions. So you can say from here 0.2 it's minus. 0.2 to 0.3, the sign changes once. There should be a one solution. Again 0.3 to 0.4, again sign changes, there should be another solution. Again that sign changes occurs at 0.5 to 0.6, one solution. Therefore, how many solutions we can expect today? We can expect 3 solutions over here. That's a way of writing the answer for this question. Is that clear?
Yeah, yes, sir.